So hello and welcome to System Design Concepts and Problems. My name is Himanshu and I'll be hosting this session. Right. So about this session, real quick, in this session, we'll keep a 1 hour time dedicated for concepts like maybe caching or some algorithm or some data structure and problems. Problems to increase the practice in this in designing questions for designing questions. So we're going to have this 1 hour dedicated for system design concepts and problems. Now, these questions, system design questions, I've asked them in interview coding lab in past, and the feedback from those labs is that we should have a proper full session dedicated to this. And also, people at different point of time ask kind of similar questions. So I've bundled that feedback and questions, and in this particular session, I'm going to go over the overview of how to prepare for system design. And so in this session, I'm going to focus on how to prepare for system design, and also we'll have few problems to go through what I'm talking about. All right, so let's get started. So system design, or let's just simply call it design. Okay. So what is system design? What are system design questions? One second. All right. So what are design questions? Right. So design questions are usually asked in interviews. There, if you have 5 rounds of interviews, then maybe 2 rounds will be on design questions. They are not essentially coding questions, but they test a different type of skill, and the skill is about designing systems. For example, you may be asked to design, let's say, a web app that can handle high traffic, maybe let's say 1,000 requests per second, right? So there are two things here. You have to design a website or a web, whatever you want to call, and then it should be able to handle a relatively higher load, right? So in this, when you're given this question, which is kind of an open-ended question, there are multiple answers to this problem. You come up with some kind of a web app which is written on some kind of a stack, plus the infrastructure like the data center, caching, databases, and all that. That as a whole will be referred to as the system here. So you have to come up with the design of how you're going to do this, how you're going to achieve this goal. So designing system with some constraints to achieve a certain goal. So that those type of problems are referred to as system design problems. Right. Now, this is just one type of an example that I'm giving. There are multiple type of problems that fall into this. So let's just quickly talk about some of these. I'm probably going to write design. Okay, so these design questions can fall into broadly three categories. One is the category of data structures. Okay. The other category can be what we call as system design. Now, people can club these two into one and call this system design. That's fine too. Doesn't matter, but we should be able to understand when the problem asked is focusing on some kind of a data structure and algorithm, or is it focusing on system components like databases, languages, and load balancers, that kind of thing. And the final thing is object-oriented design. They are also design questions which are based on testing how are you able to model real world situation into an object oriented terminology and establish relationship between different objects. So let's just quickly go over all of this. So data structures. First of all, what is being tested in this system design round? The thing that is being tested in the system design round, the main thing is problem solving, and more importantly, process for all of this. So these questions are open ended, and many people have different approaches, will have, sorry, different final solution. But what is being tested is how do you approach this solution? And that approach can show that whether you have a structure in your problem solving skills or not. So essentially, the process is the important part, and that's why we practice this thing. Okay. Now, specifically for data structures, what is what is going to be looked for is this good understanding of data structures. Like you have different data structures like stacks, queues, trees, hash maps, hash tables. Do you have a good understanding of those? And are you able to manipulate these to get the task done? Now, in the good understanding also comes the complexities. Like, do you understand the space and time complexity for these structures that you're going to use? And finally, what are the trade offs you're going to have if you choose this approach? So these are the things that that gives an evidence that yes, you have a good understanding of this data structures. Now, in terms of system design process, suppose you are asked to design a system, what is being tested is, first of all, so I'm talking apart from the behavioral skills at the moment, like how your communication and all that. I'm not discussing that at the moment. I'm just saying, in terms of, I'm just discussing the technical aspects right now. So what is being tested in system design is, once again, how you're going to approach this process of designing. And then some things like maybe your experience. Do you have experience in working with tools and technologies? So suppose you, once again, as in the previous example, you were writing the app. In writing that app, you will encounter at least 6 or 7 different systems that you'll have to incorporate to successfully achieve that result. And when you do that, you'll be familiar with those 6, 7 systems. So that brings in an experience that you know how to use this and what are the advantages and disadvantages of using those systems. So that experience. Then this basically looks, also tells the, like, gives an indication of the breadth of knowledge that you have. Now, this comes from a different process, basically how aware you are of the current landscape of technology. Like, you may not be working in it and you may have superficial knowledge, but still having a knowledge of the available tools and technology is a good idea. And you can explicitly state that you're not an expert in this, but you have some idea of what this thing is. For example, we may use the term called consistent hashing. So you may not know the idea, you may not have dealt with it, but you may superficially know what it is. So still okay to use it. I mean, you're just not an expert in it, but it's good to know that if a solution falls into that domain, then you can think about consistent hashing as well. So that's system design. And then finally, object oriented. This is process. This is very important actually. When you're writing a code in any big project, in whether you're in a company or in a university and you're writing big project, essentially you will have many entities. And these entities are referred to as, let's say, objects or classes. And they will have some relationship. Once you try to model a complex situation into object oriented methodology, you will notice that there are some problems that will spring up, and you will have to solve those problems by effectively designing a good system. By, so basically, uh, objects, like what are the objects in your system, and then what is the relationship between those objects. Relationships are expressed by inheritance and polymorphism. So once again, this also tests your experience in this, solving some problems in this area, give you good experience. So those are the 3 categories which I broadly classify design questions in. Any questions? So let's look at an example real quick. Okay, so suppose data structure. Let's look at the data structure related question. Just give me a second. Okay, I'm going to keep the examples real simple. Okay, suppose that you have to design some kind of a construct which can hold some items. Okay, suppose there is a object of type item, whatever. It can hold certain items, a maximum of, let's say, n items. Let's use the number, let's say 100 items. Okay, and you should be able to insert an item into this structure, and if this limit is reached, then and let's say if this limit is reached, you have reached the 100, and you want to insert the, let's say, item number 101st here, then the oldest item should be removed from this construct. Okay, and that should happen in constant time, let's say O1 time. Okay, then how would you go about this problem? Let's discuss this. Does anybody want to share any opinions here?
I'm not very clear about the objective here, Himanshu. So we need to,
yeah, you have to design a data structure essentially that can hold maximum of 100 items. And as you're inserting the items, if you have reached the 100th item, then the next insertion would remove the oldest item out.
Okay, the first one in this case. Okay.
Yeah. So are we just talking about the complexity of removing the oldest item, or also the insertions?
So we are talking about first of all, how would you design this? So what data structures or data models you will use? And then how will you achieve the O1 complexity in that case?
So this is LRU, like least recently used cache, like how those data structures are implemented.
Yeah, essentially this is an LRU. So in this situation, for example, you can say that you can have a queue, right? And the queue can be a doubly linked list. This is the head of the queue, and this is the tail of the queue. Now, essentially, you can also keep a counter, n. Whenever you insert an element, you can just add it to the head, right? So that will be O1 time. And as you keep on inserting, this n will grow. You will manually increase the count. When it reaches 100, and when you're inserting a new item, you will just remove the tail item. So that removal is also O1. Right? So in these type of questions, your approach from a different perspective. So when you're learning, you look at queue first, and then you solve queue problems. In these type of problems, you're given a scenario, and you have to approach to the data structure that can solve this. So in this case, the queue is the answer. Yes, any question? Okay, let's take a different example. For example, right now, let's say I'm on this browser, right? So
I have a question before we move on. So
sure.
Can you contrast using the queue versus using a stack instead? Why not use a stack in this example?
how will you achieve the same result with a stack? Let's look at this next example first, and then we'll talk about this. How about that?
Sure.
Just give me 1 second. So suppose you are here, you're on this web page, and suppose you click on this link. So you reach this page. And suppose that you click, actually, let's just do something else. Okay. Suppose you you look for, let's say, binary search. You go to the Wikipedia and let's say you click this link. So you go to search algorithm, then you click this, you go to a new page. Now notice in the browser, there is a back button. When you hit the back button, you go back to the previous page. Then you hit it again, you go back to the previous page. So how will you design that back button? What data structures will you use to design that back button?
I believe this can be a good example for stack.
Yes. Yeah, so that's why I said, let's talk about in this example. So that tells you the difference between a stack and a queue, right? So what is happening in this example? Let's look at it. So you have a back button on browser. Okay. So as the user goes to browser, okay, so suppose there is a user goes to browser, goes to site number 1, then goes to site number 2, then goes to site number 3. And then at here, you hit back button. Essentially what you're asking browser is, give me the last website that you are on. How we can achieve that is that every time this redirection is happening, we can essentially store that in some kind of a stack. So you're on browser. So first you're on site 1. So as soon as you move to site 2, site 1 is in the stack. Now when you go to site 3, site 2 is in the stack. So when you hit the back button, whatever is the top is going to come out. So you go here. So you can go back to the stack. So in this case, a stack is going to give you the very first item that was inserted versus a queue that was going to give you the last item, the very first item that was inserted. So the difference between the two is you have stack queue. Basically, you have this as first in, first out, and this is last in, first out. Right. So whenever you are solving a problem in which you have to remove the oldest, a queue turns out to be a good example. Does that make sense?
Yeah, I think I got your first question. I thought you wanted what was at the end of the last item. Well, I guess your first question was asking for
the oldest item to be removed.
The oldest, so the first item, basically.
Yeah, the very first
right?
item.
The
yes.
first item. Yeah, understood. Okay, I think I confused the two. Okay, that makes sense.
No, but yeah, that's good. So the point here being that what you will have in this situation is that you will have a scenario, and you will need to understand the scenario and come up with the logical data structures plus algorithms that are going to work in this case. Okay, and we will be solving several of these problems in which the scenario may be simple, like the one we discussed, or they may be a little complicated, and it might be hard to come up with a good solution in the first site. Right? And the way you practice this is basically, actually, let's defer that for a second. Let's look at the example for system design. Some of the very, very basic, very, very common example for designing systems may be something like, let's say, a tiny URL. Very common example. You might have already seen it. Or let's say a spell checker. How to design a tiny URL system, or let's say a spell checker. Let's just take tiny URL for a second. So when you have this situation, you need to understand that there are two parts to this. That there is a data structure part as well. So this question has a data structure part as well. Data structure plus algorithm parts. That how you're going to achieve what is being asked. And then there is a design part as well, in the sense that system design part as well, that you have to architect a system, right? So there's going to be some web app, there's going to be some databases, there's going to be some UX and all that. So you need to think in both ways. And we're going to take this example in a bit. Okay. And then finally, we have the object-oriented design. Everybody might be familiar with some of the examples, like parking garage, designing a zoo or something like that, in which you have to once again think of the different objects and have experience like how those objects are gonna interact with each other, so establish relationships. Let's talk about the preparation part. Okay, how you can prepare these things. So yeah, actually prep. So the first category, the data structures. So there is definitely a theory component here, right? You can read some theory about the databases. My mistake. Data structures. You can talk about, you can think about the time complexities. You can read about that, get some experience. Then you can do some coding. Coding will help you determine the using these data structures efficiently, and also calculating the space and time complexity. Right? The practice problems is essentially. And this, I would say, and then finally the practice problems like the one that I mentioned. That some real world scenario and how you can go back to the data structure that is supposed to be used in that particular situation. Now, coming to system design, once again, where you have to architect something. Now this I would say is the little easy. Not easy as in that this content is easy, but in terms of getting the experience of the three, this might be the easiest to prep, because you can read theory, you can code, and you can do some practice problems. In terms of system design, the real knowledge is actually if you have implemented something. If you have implemented something, then you have a detailed knowledge about the various components that are involved in architecting that system, and that gives a very solid edge. But if you don't have, that's okay. That's still okay. I mean, you can still like read about this stuff. There's a theory aspect. Plus, of course, the technology landscape is huge. You might not have worked on everything, so theory is still important. You can still read about things, right? And practice problems work here as well. Now, what helps here is that the other thing that helps here is that this I can call it, let's say, up-to-date information on tech. Or actually, let's use a better term. Let's call it breadth knowledge of state-of-the-art tools and tech. So this is also an important part, and this can be achieved by reading like the engineering blogs and like watching some conference videos. There are many YouTube videos from different companies themselves where they talk about how they're achieving certain things. And this is also going to be something I will assign as reading. in these sessions. Okay, so each week we'll discuss something. Okay, this knowledge is also, I think, the slowest to build. It takes time to build this knowledge. So what we need to do is we need to get into the habit of collecting this information, discuss actively, and over time develop a good idea of how different systems work. For example, how is the Uber is working in the background? When you call a cab, what is really happening in terms of technology to get you the cab? Or how's the Google search working? So this is the important part that we need to slowly uh, collect here. Okay, and I'll assign some reading as well if we can go through. And finally, object-oriented design. This will be the least discussed in these sessions, but essentially, once again, strong theory fundamentals on inheritance, polymorphism, abstraction, and everything. And then there is a very important part of practice problems. Now, what happens is that when we practice some problems, they don't tend to be that complicated compared to the one that we have actually that we have to solve in a university project or a real work situation where the problems are really complicated. And so, I mean, you have to do whatever you can best. So theory plus practice problems are the best you can do if you don't have that opportunity. So, but this will be the least that we'll discuss. We will cover some examples, but probably not that many. Main focus is going to be on the first two, this and this. Any questions?
So you had that easy mention in data structures. So system design and object-oriented, would that be medium or hard?
So this will be this. I would say system design. Architecting system is not something that you can acquire in a crash course type of situation or in a few days. There are many technologies available, and you once you have once you have gone through all of this multiple times, failed a bit, then you really understand how these things work. Okay, now for example, if you need to speak, for example, the first example that we were talking about, that designing an application with that can handle high load, right? If you work on such a web application that actually has to tackle high load, or if your application has actually crashed, then you must have researched these options, that what you can do to make the application able to handle the load, right? So that gives you the solid knowledge, and otherwise you'll have to slowly collect this information and read a lot, understand the problems that different companies are facing and how they are solving. So you slowly build that knowledge. In that way, it is hard. This is basically, you can read some theory from some book, you can code, you can practice, and then you can solve few practice problems. So the preparation is easy. I would say just the preparation part. The problems can still be complicated, but the preparation part is easy for this. This one is slightly more involved.
Okay, Himanshu, have one more question.
Yes.
Yes, true. Like we have many options to choose. Like when you are proposing a solution, right? But
Yeah.
but when you are going to a company like either Google or Microsoft or Amazon, right? So though the underlying technology, like the pattern, like similar, like a queues, or maybe if you look at the load balancing and all those, they may have like the technology perspective, it could be similar, but everybody have their own way of implementing that, and
Right.
they may expect their preferable like a choice pick from their own stack. So would you cover anything on that, like where you are going and what kind of a stack you're gonna pick up and what kind of tool you're gonna pick up?
So you mentioned about some of the companies like Amazon, Google, Facebook. Now, as I mentioned in the beginning, right? When you see a design question, there are multiple implementations. You can have you can have multiple implementations for the same problem. These companies like So what this system design tests is your approach, not really the implementation, unless you are missing something very, very obvious. Okay, what is being tested is the approach. And let's say you choose this implementation too, then you understand the the trade-offs that you're making in your decision, that what exactly are you achieving and what are you losing by making that choice. I don't think there's going to be a case when somebody is going to ask you uh, to implement something in a certain way. That's very unlikely to happen. It can happen in a situation where the solution is so obvious and you have somehow missed it. Then they may guide you to that particular type of implementation. Otherwise, that kind of scenario will not happen.
Okay, thank you.
And this is the purpose of this. These questions are open-ended. They don't have one solution. They have many, many solutions. You need to demonstrate your knowledge, that what you understand the full scope of what you're doing. Any other questions? Okay. Why prepare? Or why practice? The preparation and what are we preparing essentially? That also is another point. The preparation is to develop a structured approach to solving problems. This structured approach is not a rigid approach. I mean, you are not going in one direction, but there, let's say if a problem can be viewed in three different ways, then you can choose, then we can talk about those three different ways, and then you can choose whichever way you want. And we'll see that as we move along in the examples. These things become more clear when we solve examples. But essentially, develop a structured approach to solving problems. Right? When you give a solution, your solution should not be like all over the place. This thing I think will become more clear when we look into the problems. And you can also call it process. What your process to approach the problem is. The another important part of prep is recalling information. Now, this is also an important part. If I was to ask you, like, let's say some behavioral question that, can you tell me something that you have achieved in the last 1 year? You may have achieved a lot of things, or you may have learned a lot of things, but you may not be able to tell me right now because you may not be able to recollect everything that you have done. Right? This kind of thing happens when you are designing a web systems, for example, a website. There might be few things that are standard template for a website, and you can always use those things as well when you're structuring your solution. So that type of information, keeping it in place so that you can always use it, is also the part of preparation. And third is to, how do I frame it properly? Realize the depth of your knowledge. Now, it's important that we pay attention to how much we know about a subject. Okay, so suppose I can use fancy term to answer a question, but if I don't know what that really is, my knowledge is very superficial. So we need to know our bounds as well. That when we are talking about some subject, how much of an expertise we have in that subject, and we can explicitly make it clear as well that do we just know the concept, or do we have we worked with that technology? Okay, so we need to think from these perspectives, and this is going to be the practice part here. Now, some of the preparation ideas. We talked about certain things. breadth of knowledge, there are a few things that we need to look into. So first is current landscape. An overview of current landscape. So it's a good idea to know what different technologies are. Right. So for example, what is caching? Like what are the caches right now? Not everything, but some idea of what these things are. For example, databases. There are two types of databases, and what are they good for? What is one database good for? What is the other database good for? That kind of thing. Right. Some concepts, like what is hashing maybe, or what is, let's say, horizontal scaling. What is horizontal scaling and how it can help? Then we can talk about some tech. This is the information specific thing, like for example, cloud, or let's say some cloud. What is the advantage of using that cloud? Some databases, something like that. And finally, some languages, like what is a scripting language, what is a compile language, and which language would you choose to do certain thing, right? So programming language. So for example, if you're designing a prototype, scripting language might be fast, but if you're designing a very high load application, you might be using a compiled language, that kind of thing. And this is everything here. So cache, for example, caches or load balancers. I tend to talk about the web a lot because I do deal in web, but we'll look in the different type of examples, not just this. Right. So this is what we are going to cover every single other week as we move along. All right. And finally, there is how to approach a system design problem. Right. So system design questions, they tend to be vague. Okay. And there is a reason they are vague. You might be asked to implement some kind of a system. Once again, let's just take the example of, let's say, tiny URL. So the question might be to design a tiny URL system. Now, this question is pretty vague. I mean, you need a lot of information to really approach this problem, right? So at this point of time, you need to talk to your interviewer or whoever is asking to basically give more details, like what are they looking at? Once you have a good idea of the system, then you need to break this problem down. Now, there are multiple ways in which you can break this problem down. Okay. The one approach is the approach of user. So when you're designing a, let's say, a tiny URL system, what is a user going to do in that case? The user is going to have a big URL which will be passed to your tiny URL system. There will be some URL which will be passed to some tiny URL system, and then there is a short URL that will come out. Right? That's what user is going to look for. And later on, user will pass the short URL to your tiny URL service, and that should return the exact URL that was stored for that tiny URL. Essentially, those are the two operations the user is going to do. So that will help you come up with the functions that you need to support. Okay, so the one function can be to generate short URL, and other can be to get URL. One can be, let's say, generate short URL, and the argument can be URL, and the other can be get URL, and the argument can be the short URL. Now you need to come up with ways to implement these. And when you come to the implementation, then you can think about that if you're getting a URL, you need to shorten it. What can you use to do that? And if you are given a short URL and you need to obtain the bigger URL, how are you going to store this mapping? What are the backend systems where you're going to do that? Okay, so that's one approach of breaking things down. Right? The other approach of breaking things down is called the bottom-up approach. Or you can also call it first principles. When a question is vague, you need to think about what is being done, like from the engineering perspective here. Like, what are the basic questions that we can ask from this system? And then we can build from there onwards. So similar questions, let's say tiny URL, you can once again look at it in the same perspective. You can say, okay, this in this question, essentially the service needs to compress a URL, make it a shorter string, and then given a shorter string, give the original URL back. That's the only two things. And as we go along, you may be asked a vague question. For example, you need to design something like Uber, for example, where you have an app and you have your location. You need to, once you press, you need a cab. How is Uber going to locate the cabs in your vicinity and gonna bring that cab to you? This is a vague question. Once again, by vague I mean that this is a very broad question. So you need to think from the first principles here, or from the user perspective, one of the two approaches to really go through the details, the technical details here. Right? Then you need to think about that is kind of interrelated, but what is the computational part here? And what is the other logistics part, like UX plus, let's say, monitoring, all that. And I'm going to also talk about another related topic here. So in the case of, let's say, tiny URL, the computational part are these two functions here. Something that is going to do the operation. But then you have to have a good UX where a user can go enter their URL, or the other web services can call you with some URL. You need to have some monitoring in place and rest of the stuff. So there is an algorithmic part, and then there is other parts to that. And that brings to let me say this, then when you're solving some problem, look for templates. How are certain things achieved in the world by the websites, by the services that you already know? So in this case, for example, you have to design, let's say, a tiny URL service. You can literally look at the example of the various URL services, various URL shortening services that do that. Or suppose you have to do, let's say, some kind of a autocomplete feature. Okay. Suppose you are asked to design an autocomplete feature where somebody is entering text and you autocomplete it. Then once again, you can think of what autocomplete features do you already, what systems do you already know which implement this? Right. So you can use that as an example. So keep a list I mean, having this kind of recalling is good in that sense. So you can always go back to those systems and get the idea of what you expect from those systems, and similarly you can emulate the user who will be using your system, what they would be expecting. And finally, think about the trade-offs of your choices that you have made. Whenever you choose something, whether you choose an option A or option B, you're going to achieve something and you're going to compromise something. So what are the compromises that you're making in that approach? It's okay to make compromises, but you just need to know what compromises you're making. And finally, some information like you can say learned information. Sorry, memorized information, better term. There are certain things that you need to make sure that you know, right? Because let's say when you are dealing with data, you would need, whenever you're designing any system, not just dealing with data, when you're designing a system, you may need to compute something, like let's say size of the disk, size of the cache, size of the memory, or the processing speed. So it's always handy to know certain things beforehand. Like this information should be with you. For example, let's say suppose there is a string. Let's say there is a URL string, something HTTPS, and you want to compute the size, average size of this URL string, then you need to know the average size of a character, how the character is stored, right? So some things to keep in mind when doing this is basically size of data types, like how big is int, how big is double, how big is not double, but how big is generally is int, characters and all that. And some of the other important things, for example, just this type of information should already be memorized. For example, 2 to the power 32, how much this is 4 GB, right? This number comes a lot. 2 to the power 30 is 1 trillion. So that type of information, this helps. And as we move along, I'm just giving an example right now. As we move along, I will give these little tips that you can use when you're working. So they'll be helpful. The other thing is, for example, the important thing is the time and space complexity. Similar thing. Like if you're looking up in a hash table, what is the worst case scenario in a hash table? Like what can be the time complexity in a worst case scenario? You should know that beforehand. This type of information you should not be computing while you're in an interview. Any questions?
When mentioning about the bottom up in the tiny URL, how would that work?
So bottom up, it's a fancy word, but essentially what that means is you're given, let's say, a complicated scenario. Okay, you need to approach from the most basic facts of what this thing is supposed to do, and then how you can achieve it. Okay, let's say so you're doing a tiny URL. What is the most basic thing do we know? What is the problem at our hand? The problem at our hand is that the URLs are big and they are hard to remember. So can we compress them into something which is very short and easy to remember? Right? That's the scenario. or you can pass them. Right now, you use tinyURL for other purposes as well, like tracking and all that, but that is the heart of the problem. So essentially, we need to take a big string and convert it into a small string. Right? Convert it into a small string. And then we need to store this information in some database, such that when the small string is presented to us, we need to be able to go to this database and come up with the corresponding big string back. For example, I go to browser and I type bit.ly.com/ let's say my YouTube channel, lbc-youtube. So that's a tiny URL. I give it because people can remember it. When you hit it, this bit.ly.com is going to be hit with my short URL string lbc-youtube and you're going to get the original URL back. Right? So that is thinking from the basics. You try to understand what is the problem being solved and how you can achieve this problem. So clearly, one thing that probably is pretty clear is we can store this like a hash map here somewhere, and the key can be small and the value can be the original string. That gives you the answer. I mean, that way you can approach the problem. That doesn't give you the answer, but that's points you towards the direction of the answer. Does that make sense?
Yeah, absolutely. Thank
you.
Is the bottom up same as the user approach, like, to see how the user would use this solution?
In this case, they look to be pretty same, but user approach is looking from the perspective of end user. So suppose there is a system, right? You don't know how it works in the end, and you just want to guess what you need to implement. Right? Let's say you don't know what to implement here. Okay, then you come from the user's perspective. Okay, suppose you're designing YouTube. Okay, suppose you are asked to design YouTube. Okay, then how can you go about it? If you think about it, what does a user do on YouTube? That's one approach of thinking when you're approaching this problem. What does a user do on YouTube? User goes to the homepage. Then the user goes to the homepage. The first thing is the feed that they see. Then they can search something and the result should come back. And then they can play something and they should be able to view the video. Or they can make a, like, let's say they can add something to their queue and they get the queue back. So this lets you think about what to expect from that system. Now, from the very basic perspective, if you look at the bottom-up approach, what you're saying is YouTube is a service which streams video. So essentially, on a network connection, you need to stream video. And then if you need to stream this video on a request, this new video needs to be stored somewhere in a database. So I think you're probably getting the idea now, yes, right?
Yes.
So there are different ways of looking at system. If you cannot think of one way, then you can go to the other way, but different perspective. Look at the problem from different perspective to come up with a better idea of how to approach this problem. This will let you know what kind of APIs and functions can be created. And then finally, one thing I think that missed was whenever you're designing system, there is a core part and then there is logistics. I think I did mention. I'm just calling it logistics for lack of a better name, but this includes everything. This includes, let's say, load balancers, okay, fault tolerance, fault detection, let's say, or we call it monitoring, or security, availability. So all the systems fall in this category where they are doing some core work, but they also need to have this logistics part. So you can always think about these as well when you're designing your systems. Okay. Now, if somebody is asking tiny URL, they're probably not interested in the other process, but still it's a good idea to think about these things. For example, in the case of YouTube or any other system, you can think about monitoring, right? What if some component is down? Then how do you detect it, first of all? The let's say there is a website, there is a UX, then UX talks to some layer, some service, that service talks to some DB, and then there are multiple DBs like that. There's some caching somewhere. But what if some component fails down in between? Then how your app is going to react? Right? So this is common for all the apps. It differs. The implementation may differ based on the nature of the app, but still some fault detection is always there. How are you going to make your service available, for example? How are you going to ensure that something is available? Right? So that kind of thing. Any questions? Okay. If not, then what I'm going to do is I'm going to end this session. And then in the next one, what we'll do is, as I mentioned, we're going to focus 10-15 minutes on some kind of a concept. And I'm going to take hashing. Okay. Hashing gets asked as a standalone question as well that implements some hash. And then we're going to look into a couple of problems. Okay.
Will the data